Hello and welcome to week 2 of LAT 2150. My name is Todd Hurley. I'm your instructor for the class. This week's lecture covers chapters 3 and 4. So let's go ahead and get right started into the lecture. This one should be a little bit shorter than last week's lecture. We'll go ahead and flip through to the slides. First slide here, first slide is week 2, chapters 3 and 4 from Raymond E. Foster's Police Technology book. Assignments, we have assignments here, same type of thing. If you look on Blackboard in the assignments section this week, you'll notice that under the week there are the PowerPoint presentation as well as the assignments. We have one discussion board assignment for this week. Again, the generic symbols for the class, the two opposing faces indicate in the PowerPoint slide will indicate where and what your discussion board item is this week. Chapters 3 and 4, again, one discussion board this week. That's pretty straightforward. The learning objectives this week, one is going to be basic radio theory, and some of this theory that we go through when we talk about analog and digital communications. Some of it is a little bit dated, but we'll continue to kind of use that as the model, and then I'll try to point out some differences and some things that have changed and some newer stuff that we are running into these days. So I'll try to update the information a little bit. Basic parts of radio frequency communication, digital communications, including TDMA, FDMA, CDMA, and CDPD. Those are all spelled out there. You can see that what those are. And then some of the nuances of cellular telephone systems. Radio basics. There are two medias for transmission of electronic information. Information can be done over the wire, straight, just like a phone conversation. You still have a landline in your home. That's a wired type communication, or a wireless type of communication for radio communications as well as now cellular communications. That's probably the one big area here is that in 2005 when this text was written, landline or wired-based communication was a lot more prevalent. Now we're seeing a lot more move towards the wireless technology. So again, we'll try to make some of those notes there. Basic wireless radio basics when it comes to wireless communications over hardwired communications. Wireless broadcast over a wide area to a large number of users. So that's one of the big advantages of wireless or RF or radio communication or broadcast, is that you can broadcast that over to a large number of users. And then because wireless communication uses radio frequencies, is often referred to as RF communication. So again, you'll probably hear me say RF versus whatever, landline radio frequency. So that's what we're referring to when we say RF communications. Radio basics, radio waves. Radio waves are in the way in which analog and digital signals are carried. As wireless communications, you can equate those to waves in the ocean. Voice and data information can be carried by either. So or either. Let's start over. Voice and data can be carried through radio transmissions. Both have advantages and disadvantages. Analog radio systems consist of a microphone that modulates or changes the human voice into an analog wave, which is processed and sent to an antenna for transmission. The return of the signal is passed through the antenna, received, processed, and broadcast out to speakers. So there's a diagram in the book that shows a basic radio diagram with a switch between the transmit and receive icon. So it's good to kind of review those diagrams in the book. But that's the basics of a radio thing. So first, this is our discussion board for this week. And so the question here is, are radio systems becoming so technology-based that small public safety agencies eventually contract for these services and lose functionality? This is a big question right now, not only based around what we're seeing here with technology advances in that, going from a straight analog UHF or VHF, and we'll get to those a little bit later here in the discussion, radio systems to now full out P25 digital systems that are encompassed in a larger system. Well, at least in Ohio, a very well-known P25 system is the MARC system. Then you have other digital systems. So the technology definitely is changing, and it's forcing some agencies to rethink their things. And I'll give you a little bit more information when we get further on in the chapter here about what we're doing here in Grove City. Back to radio basics. Analog radio system can carry digital signals, but the first digital signal must be converted from analog configuration to its digital configuration, and the way that that's done is a modem. So, although many people associate a modem with a dial-up phone line, everybody still that has even broadband communications has a modem. You have that cable modem, which is converting the analog or the RF signals to a digital signals that your routers, your computers and stuff that are connected to them can understand. So the modem here is the important thing to understand. That's where the conversion of that signal is done. Radio basics, another part to this is, on analog signals, the further you are from the transmission point, the weaker and weaker that signal becomes, and at some point, that signal strength becomes so weak that it gets lost in the background static, and that's what this diagram here, this particular slide, is trying to illustrate. A digital signal can be broadcast only up a certain distance, and it's no different than an analog signal. So once the distance is reached, typically what you see in a digital type of transmission is that boom, it drops off. There's no sudden fade. Either your equipment can recognize it, understand that digital transmission, or it can't. So it's a lot more abrupt in its drop off. Again, radio signals travel like waves, like sound and light. Radio waves are like ripples in a pond, with two important differences. The first one here, I'm sure you're shaking your head. Okay, you cannot see radio waves. That's clearly, hopefully, if anybody does see radio waves out there, let me know and we'll get you help. Radio waves stay constant. They do not distance themselves or go further apart. So that's something to keep in mind is, the length of the radio wave is constant through the transmission in that particular frequency, in that particular bandwidth. Here we talk about radio waves in a constant pattern. So the oscillating pattern that you see on this slide here, it's a typical oscillating wave. The frequency is measured in hertz, and that is going to be the cycles per second. So if we start here at the very far right of the white diagram, when it goes down and back up, that's one cycle. So electric power is another thing that is on 60 hertz. So that means the radio wave or the formation of the power in your thing is going through up and down 60 times a second. So again, hertz is the measurement of that. Other basics, AM and FM radio systems work in different frequency ranges. The ranges are banded together in bands, and they're typically banded together based on characteristics. They share certain broadcast characteristics and other characteristics. So it's important to know that. There is a diagram in the book as well that shows from UHF, VHF, 800 megahertz, all those different bands and the characteristics of some of those. So just take a look at that. We won't be asking the specifics of those, but it's kind of neat to look at that. Different groups of frequencies are called channels. The number of frequencies in a channel are referred to as its bandwidth. So in a particular frequency, the number of channels that you can fit in that frequency will determine the capacity or the bandwidth that particular channel that particular frequency can carry. At the edges of these frequencies, there are guard bands, and these prevent the channels from overlapping and confusing information in exchange. So it's important to note that you'll be looking along, and then all of a sudden there'll be a dead spot, and those guard bands that kind of protect from the overlap. Effective power radiation. how far from the source a signal can be received is interpreted. So low frequency has a higher effective power rate. How I choose to kind of remember that is, if you think of your car stereo, so you're out in your car stereo, you have a big subwoofer in the back, and in the car you can hear lows, middles, and highs. But if you're outside the car, you have the windows rolled up, and somebody comes rolling by who has a heavy bass, you hear the bass. Bass is a lower frequency. It has better penetrating or better radiant power, so it has the ability to penetrate and be transmitted in further distances. So it's important. That's how I kind of make that thing. Lower frequencies have a larger or higher radiant power, but there are drawbacks to that as well. Wireless signals can be sent here's a couple different groups. You have UHF and VHF, and just it's important to understand that VHF is very high frequency and UHF is ultra high frequencies. Many cycles per second, so you remember the white little up and down trough. So the frequency measurement is very high. The number of hertz and each of these frequencies are going to be higher in those bandwidths. Frequencies within a band have a propensity to skip. Skip occurs when a broadcast reflects off the Earth's ionosphere. Each time that I go through this, I look at this and I look at this slide and I go, okay, that's great. So again, I won't ask you to know that, but if it's important to understand that if you have some skip, some chop or chatter and within a transmission, that's possible that it's something that is bouncing off the Earth's ionosphere. Noise interference is a problem with lower frequency. So AM is the lower frequency than FM. So you'll see that if anybody turns on a radio, you get a better sound out of FM. The lower frequencies, the AM frequencies, there's a little bit more interference there. Communication hardware basics. So a transmitter is what generates the radio wave or the signal. Receiver is what receives it, changes it back into its original form. So receives the signal, plays it back through a speaker. A transceiver is a combination of both, so it's doing transmitting and receiving. Communication hardware basics. Job of transmitting is to generate the signal. They have oscillators that will take analog signals or voice signals and generate those into a RF frequency or an RF signal that can be transmitted. Part of the transmitter that generates those is called the oscillator. The whole process is oscillation. Communications hardware basics. The transmitting of data can be done through FSK or frequency shift key. It's a method. Two separate frequencies are used to represent the ones and zeros. So they have one frequency will spike if it's a 1, one frequency will spike if it's a 0. That's how the ones and zeros or the digital data is transmitted. To change voice into a digital use, we use a voice coder or a vocoder. Sometimes you hear vocoder. It's a reverse of a modem. So it's changing voice into a digital, whereas a modem is changing digital into a RF or what can be transmitted. Different antennas have different propagation characteristics. That's why you see different antennas on cars, radio towers, depending on if you want omnidirection, unidirection. There's different types of antennas. The basic antenna, the straight wire, the ones that you see like on your radio and on your car, is a dipole antenna. You can increase the range of transmission by adjusting the gain or the power, the output of the signal. That should be pretty self-explanatory. It's like turning up the volume on your stereo. You're turning up the gain on the signal. It'll allow it to propagate further. Simple voice. We're talking about radio frequency systems. Simple voice here is users can transmit and receive information on a single channel. So it's a single channel. I'm talking on it. Everybody else has to listen. When I let go, then I can listen. So it's a simple or a simplex system. A repeated system is a signal very similar to a simplex, but it's put into multiple sites. It can be repeated from one system to the other. The bottom one here, trunked radio system, is probably the most prevalent and one that you'll see most often in public safety. Is for instance, in our system here in Grove City, we have a 5-frequency trunked system. One frequency is always set up for the data, so the data is being transmitted across the system to say who's talking on what group, who has hold of what group. The other 4 frequencies are used to handle 4 different simultaneous connections. And as I pick up and I grab it, I go to talk. I talk on that particular frequency. It holds that frequency until I'm done, and then the next time I key up, I may be on a different frequency. So a trunked radio system is allows for a lot of capacity through a small number of frequencies or channels. Frequency division multiple access. So that's one of the digital ones that we talked about. Increase in spectrum efficiency. Typically, in a 30 kilohertz radio system, they're divided into 10 kilohertz channels, so it divides up the frequency band there into smaller ones and increases the number of frequencies that can be used in conjunction with the trunked radio system. Time division multiple access. So TDMA is in this particular case, TDMA is taking advantage of the spaces between words. So it is a timed out system that allows for, there may be multiple conversations. So as I'm talking now, and I take a pause there, that empty space or pause then could be filled with other transmissions. So that's what a TDMA type of system will do. It'll fill the spaces and it'll try to maximize the capacity of that transmission. And then code division multiple access. CDMA, it spreads out the transmission among all the available channels, so it's trying to burst out that information, get it out using as much capacity as it can. So it's trying to take full advantage of the capacity of the radio system. Cellular technology. Just some basics here. Cell site is the physical location. So you drive by, you see the cell tower, that is the cell site. And a cell site will typically contain at least 3 antennas of 120 degree spectrum span, so that they can broadcast the full 360 degree direction. The cell area is the area that's provided by that cell site. So the cell site may be a small area, but it may radiate several miles in all directions. So that's important to understand that the cell area is the area that's covered by a particular cell site. Cellular technology, the configuration of a cell site has some of the characteristics of a repeater antenna configuration. We talked about the repeated system where a signal can get repeated from one system to the other. So there are a couple characteristics of cellular technology that are really important. One, it's the second one here that has a highlighted frequency reuse. The primary characteristic that identifies a cellular system is the frequency reuse. So frequencies can be reused quite rapidly, quite frequently, and that's a big thing with cellular technology. And it also has the other big characteristic about a cellular technology is the ability to hand off cellular calls from one call to the other. So if you're driving down the road, you're not staying on the same cell tower the whole conversation. You'll switch, and cellular technology has the ability to hand off those calls, and most of the time very seamlessly. CDPD, or cellular digital packet data, is a data network. There's no voice. It's IP based. It was the first data type network in cellular technology. We've kind of had several generations since then. I'm sure that, or maybe you've heard of EVDO. Now you see 3G, 4G type of technologies, LTE. Those are the different iterations of cellular digital network data transmissions. So the 3G, 4G is referring to this the generation of the product. So it's important to understand that LTE, I think Verizon calls that long-term evolution. So those are the different generations of the digital networks. That covers Chapter 3 I know I kind of covered that relatively quickly, but it's some of the things. Just look back in the slides. There'll be a couple questions on the quiz next week from the slides, as well as knowing where that information is in the book. So again, I'm going to reiterate: it's important to make sure you read the book, at least know where that information is in the book, so you can go back and reference that. Next, chapter 4, we're going to talk about networks, just basic parts to networks. Some of the learning objectives here are understanding the importance and use of networks, understand the difference between technologies used to establish networks, being exposed to several different types of networks, and then understanding the necessity of networks, security, and several of the means of providing networks. I think you guys have been exposed enough to the internet to understand that the internet is just a collection of different networks, different types of networks, all being able to talk together and share information. So a network is about two or more people establishing a way to communicate. Small networks could be two computers, as well as if you encompass the internet, you're talking about billions and billions of computers. Networks are founded on the concept of client-server architecture. Client-server type architecture. If I'm sitting on my laptop at home and I'm browsing the web, as I make a request to a web page, I'm requesting a page from a server. My laptop or my iPad or my phone, whatever, it is the client in that type of architecture. And each individual piece of that is a node, whether it's a server or a client or phone or whatever. Those are nodes that are on a network. So you pull out your iPhone or whatever, and you're on Twitter on that. You're on a node on a network. You're on Verizon's, AT&T, Sprint, whoever your provider. You're a data device or a node on their network. It is the server's job to provide the appropriate services to those different devices. As you can see here, the server's handling email and passing it out to the appropriate client. So the server is a more high-powered computer that's going to handle a specific task based on what it's configured to do. Why network? Obviously in the first chapter we talked about one of the most important things that for law enforcement is information gathering. Whether you're a patrol officer on the scene gathering information, a detective, whatever it might be, information is key here. So to have the establishment of networks out there so that you can use those networks, whether it's LEADS network, it's the network that's run by the Ohio State Patrol that, when an officer pulls you over and, he runs your license plate, he's running it through the LEADS network in Ohio, which is also attached to NCIC, so that we can look at national data as well. Networks also provide organization with the capability of to back up data. Clearly, in any computer system, hardware can be redone, the software, the applications can be reloaded, but the data that's generated in those is the key. And so it's very important to have that backed up and to, have the capability to, if something goes down, that something can pick up or take over the processing of that load. Let's go back to analog and digital signals. Analog signals weakens as they travel. Remember the one slide that as the signal propagates out, it gets weaker and weaker. It's important to understand that the same is true even if it's flowing through a wire here. So there are certain limitations to some of those, whether it's the air, wire, coax, cable. Digital signals are subject to that same decrease as analog signals. Digital signals are primary means of transmitting data communications, ones and zeros. All data, when it's broken down to its core piece, is a 1 or a 0. It's a yes or a no. It's a logical representation. The thing that's important with digital is there are fewer errors with digital versus analog, and can be transmitted at higher speed. If I only have to tell you 1 or a 0, I can transmit that at a much higher speed. And the peripheral devices tend to be or have to be less or can be less complex. The analog wave is called baud. We start talking about some of the analog stuff here, and I'm going to kind of breeze through this relatively quickly. I think a lot of this is somewhat dated a little bit. The analog stuff is slowly rolling off, and most of the communication stuff out there is now digital. Our technology adds up to, let's skip through this slide here. Error detection, bit parity is something that I won't test you on, but it's something to understand that it's part of error correction. It sums up the number of in a packet of data and puts that on the end, and that's one of the methods which error correction is done. Data transmissions are very similar to radio transmissions. You have simplex transmission. That means that information can only be traveled in one direction. Half duplex means it can travel in both directions, but only one at a time. So it can be transmitted or received, but not at the same time. Full duplex is data transmitted at both directions simultaneously. So most of the time, most data transmissions now are full duplex transmission systems. Even data across the internet. Your computer connected to a LAN connection, a desktop computer, that is going to be typically, it auto negotiates to a full duplex connection. Designing a network, look at the three things: the fastest throughput and response, least cost path, and design reliability. So when designing a network, those are probably the three most important things that they look at. How fast we can allow the data to flow. Do we have to have routing and switching and things that tend to slow that down? The cost. If we have a link here that's a little bit cheaper than the other, we'll put some costing parameters in there so that we maybe want more of that data to travel across the least expensive path or the most fast. And design reliability. Do we have the ability to sustain some sort of hit to our network and still maintain the reliability of the network? Things that connect. Networks accomplish data transfer with a concept called packet switching. So, it's like handing off a message. You walk up, you hand one message. Hey, this is your message. I run back and say, yep, that's what I wanted. Here's the next piece. That's packet switching. Unused available portions of the network are chosen, and data to handle that overall packet switching. In networks, the connection point between your computer and the network is commonly referred to as the modem, or in a computer now, it's typically going to be a NIC card or network interface card that then is what interfaces to your say in your home, maybe your wireless router, or to the cable modem that you have in your thing, or DSL modem. Modems become asymmetrical digital subscriber line. ADSL just means asymmetrical. Most broadband modems are asymmetrical, meaning I can download at 15 megabits per second, but only upload. So there's a difference in the speed. That's what asynchronous modems are. So most broadband modems are asynchronous, unless you're in a fiber solution where you have multiple. Our fiber solution here is 50-50, so it is not asynchronous. DSL, digital subscriber line. That's one of the types of broadband connections that are put out there today. Typically run through copper, your phone lines that come into your house. Other components to a network, you have a hub. A hub is going to be a small device that will allow multiple computers to connect to it and talk to other computers. Typically, it's included in most hubs, or most hubs today have a switching function, and it dictates what traffic can flow which way within that hub or switch. A router is a bridge between two networks. The router determines the best path between the two networks. It will allow certain traffic and will stop other traffic based on the routes that are set in that router. A remote switch is the one that's at your location but controlled by someone else. So we have some remote sites here at the city that we control the communications at those remote sites, and we call those remote switches or remote sites. A trunk is a circuit between two different switching equipment. So you may have heard it referred to as a trunk line, or a backbone or a core line. Middleware describes the software that is used to connect different applications. It's the translator. Talk too much about data compression. It's obviously data can be large, and if we can reduce the size of that, compress that before it's transmitted, that will also speed up the transmission or the speed of networks. Bandwidth. Bandwidth refers to the capacity, whether we're talking about radio transmission, the amount of radio traffic that can be generated, or data. It's the same concept. The more bandwidth, the more data, the faster that network is. Protocols, and this is probably the most important part to this particular chapter, is understanding the protocol, what a protocol is. A protocol is just an agreement between people on how transactions should take place. The standard on the internet is TCP/IP, or Transmission Control Protocol, or Internet Protocol. So it's important, all traffic that goes through that goes through the internet is typically IP-based communication. The next part here that we talk about is the structure of networks and the type of networks. It's important to understand a local area network is going to be a more of a horizontal network or a flat network that allows devices to receive network transmissions. Local area networks are in the same geographic area. So within a building, you may have a local area network within a couple buildings next door that are connected. So a LAN network operates in one specific location. It's important to understand it. A WAN, or a wide area network, is used to connect geographically separate networks. So I have my network in Columbus talks to the network in Cleveland over a WAN. Cleveland is a local area network. Columbus is a local area network, but they speak over the LAN, or the wide area network. So it's important to understand the difference between those two. Then you have wireless local area networks, or WLANs. Those are a lot more prevalent as wireless technology takes off. It was 802.11.a or B, then A, G, N, and now AC is the next one, which will put out up to gigabit speeds over wireless technology. So the wireless technology is really taking a jump, and you'll see that be more prevalent in the future. Last part to this is digital security or data security. There are a couple different things that are important when we talk about network security or computer security. The most important thing, obviously, behind data security is protecting the information. The first part to that is physical security. So, anything we do to physically protect the system information, placing servers, routers, all that things behind locked doors. Most data centers, you just can't walk in and take a look around. That information, that stuff is typically housed behind more stringent physical security. Then there's the virtual side to that. You have firewalls and encryption. Firewalls are devices that prevent access to networks based on a lot of different parameters, a lot of different authentications, and so forth. So encryption, obviously, if you encrypt data, that makes data unreadable without the code or the secret key. And then this is something actually that we're in the process here at the city of actually implementing, is IPS/IDS solutions. So intrusion detection systems, or intrusion prevention system, so that we can tell who's trying to hack into a system, who's trying to penetrate a system, do detection, do correction of online correction, or on-the-fly correction to some of those things that might be occurring when suffering an attack. So there's a lot more sophistication these days in terms of intrusion detection and prevention as well. That pretty much covers it. I know I ran through that relatively quickly, but it's important. You just, like I said, you'll have some basic questions out of this last two chapters. So it's important, if you have any questions about that, any of that information, please take the time when you do your discussion board this week to really think about how complex and how much radio systems have changed. One of the things, in Franklin County, where Grove City is located, we have 5 major public safety radio systems. I'm not talking about the ones that you're listening to the sports radio channel or your favorite radio station. We're talking about public safety radio stations. There was 5 major players: City of Columbus, Franklin County, Grove City is one of them, Ohio State, and can't remember the fifth one. Anyway, we are migrating away from owning our own radio system to we're merging with Franklin County into a Mark solution. So it's one of those things that and we're a city of size of about 40,000, and we've gotten to the point where the technology has gotten to the point where we're going to get out of that business of managing that, so that we're not paying people to maintain that expertise. It frees up or gives us the ability to have a little bit more flexibility in how we choose to spend that. So it's important to take a look at that kind of stuff. If you guys have any other questions, feel free to let me know. If there's, I promise that as we go down here, the information will get a little bit more exciting. I know this 2 weeks, the radio basics and the network basics are kind of dry, so that's why I try to get through those relatively quickly. So hope you have a good week. Remember, next week, week 3, that'll be a quiz. So there'll be only one chapter next week, a relatively short chapter, and then quizzes on Thursday and Friday. So if you have any questions, let me know. Thanks.